We're now going to be looking at different types of triangles and how their sides and angles relate to each other. So here we have a triangle. We're just going to worry about naming. We have 3 sides and 3 angles. So we have side AB, we have side BC, and then we have side AC or CA. You could say any of these in reverse. It doesn't matter which vertex you say first, as long as you indicate that it's a side. Then we have our 3 angles, A, B, and C here. So angle A, B, and C. Triangles are named based on their vertices or their points. So vertice 1, 2, and 3, which are labeled with A, B, and C. So this would be triangle ABC. Now, another fact about all triangles is that interior angles all add up to 180. So yes, these might not all 3 be congruent angles or angles of the same measurement, but at the end of the day, no matter what they are, they all have to be 180 degrees. So now let's move on to more specific types of triangles. So the second one here, we have triangle ABC, which is a right triangle. So they're telling us that our right angle is A. So because it's called a right triangle, it has one right angle, which is equal to 90 degrees. Now there's more types of specific special right triangles, but we're not going to get into that just yet. So in a right triangle, the side that's opposite the right angle, we call the hypotenuse. So this side BC is the hypotenuse because it's opposite the right angle. And then we have these 2 acute angles here, B and C. Now, we don't know those measures yet. This is just a general example. And like it says here, they will always be acute angles and complementary. It's pretty self-explanatory because we have this one being 90, and we need to make up the rest of the 180 degrees with these 2 angles because the total of all the angles is 180. All we have is 90 left to make up. Now we're on to isosceles triangles. So what are isosceles triangles? Isosceles triangles have 2 congruent legs or 2 congruent sides and 2 congruent angles. So how do we know which ones are what? We look at our 2 legs, and the angles that are opposite the 2 congruent legs are congruent angles. So for this example here, we have, let's say this point is A up here, we have sides AB or legs AB and AC are congruent. That means that they're opposite angles, so angle B and angle C are congruent. Now, we call the side that isn't the 2 legs the base, and we call this top angle that's opposite the base the vertex angle. So the key thing here is to remember that we have 2 congruent sides, which leads to 2 congruent angles. So if we go down here, we have one more triangle to look at, and that is an equilateral triangle. So we think equal right away. Equilateral triangles have 3 congruent sides, and if they have 3 congruent sides, then they have 3 congruent angles because their angles opposite the sides are all congruent. So quick fact about triangles. Just like we saw on the isosceles, if we have congruent sides, opposite those congruent sides, the angles are always congruent. Now in a equilateral triangle, if all 3 of our angles are congruent, we already know the measure. They don't have to be given to us. If the total measurement of all the angles or all the interior angles of a triangle equal to 180 degrees, if we divide this by 3, an equilateral triangle will give us 60 for our sides. And again, that's because all 3 sides are congruent, and opposite congruent sides in a triangle gives us congruent angles. Okay, so now we're on to some practice problems of relating triangles and their angles to algebraic expressions. So we need to make connections between the specific types of triangles we just looked at. So for number 1, we're given angle measurements, x plus 51, 84, and x plus 39. And we need to determine angle A. So what are we going to do here? We have to realize that the interior angles of all triangles equal 180. So what do we do here? We add up all 3 sides and solve for x. So you see the work up here. We added them up and we got x equals 3. we cannot forget to plug back into what we're looking for. So we were looking for angle A, so we have to plug into x plus 51. That gets us 54 degrees for angle A. For number 2, we have 2 triangles here, and we're looking for this missing angle up here with the question mark. Now, for the bottom triangle, we have 20 and 40 for those 2 angles at the bottom, and we're missing the third one. So we have to use the same method we used on the last one. We have to realize, again, that all triangles have interior angles that add to 180 degrees. When we do that, we get 120 for this angle here. And if you remember from a couple days ago, we learned about vertical angles. This is a vertical angle situation. It's 2 lines that intersect at a point. So we know that these 2 angles are congruent. So we get 120 here. So now in this top triangle, we have 120 and 39. So you see down here, if we add those 3 angles and set that equal to 180, we can get the missing angle. And that missing angle is 21 degrees. For number 3, we have an isosceles triangle. So as soon as we're given a specific type, we have to remember what that means. An isosceles triangle has 2 congruent legs and 2 congruent angles that are opposite those legs. So if we look here, here are our 2 congruent sides, AB and BC. Opposite those, we're given 46. So that means this angle also has to be 46. So we already got that x is 46 degrees. And then the third angle, we add those 2 and get the last one by setting it equal to 180. We do that and we get y equals 88 degrees. For number 4, we have the same thing. We have to realize we're told it's isosceles. So our congruent sides are already labeled. We look opposite, and we know those angles are congruent. But for this one, we're only given the top angle is 40. So we have to make up 140 degrees between both of these angles. So what we do is we divide 140 by 2. We get 70, 70. Those are congruent. And the one we were given is 40. So moving on. Number 5. We're given a triangle and we're given 2 congruent angles. So right away, 2 congruent angles means 2 congruent sides. This is an isosceles triangle. We're given that DE is 9. So if we're looking for side DF, we're given EF is equal to 5. That means that this also has to be 5. Again, because it's isosceles, they're opposite congruent angles. Number 6, we are given specifically that it's a right triangle. So a right triangle has a right angle. A right angle is equal to 90 degrees. So if we draw the picture here, triangle RST, here's my right angle, which is 90 degrees. And then I have congruent sides RS and TS. So I have this angle and this angle. So what do we know from isosceles triangles? We know that opposite congruent sides is also congruent angles. Just because it has a right angle doesn't mean it can't be isosceles. So we now have another 90 degrees to make up between these 2 angles. So we see that it's 45 and 45 for the both of them. Number 7. Number 7, we draw our triangle ABC there. We're told AB is congruent to BC. So right away should pop into your head, 2 congruent sides in a triangle, it's isosceles. That means we also have 2 congruent angles. We are given that angle A is 5x. So that means angle C also has to be 5x again because it's isosceles. We're given a label for our third angle, which is 3x plus 50. So now I go ahead and add those up, 5x, 5x, and 3x plus 50, and set it equal to 180. So that's my work here. And when I solve, I get x equals 10. But now we're looking for angle B. So I have to go ahead and take that 10 and plug back in to angle B. So angle B was 3x plus 50. I plug 10 in, and I get that angle B is 80 degrees. So let's take a look at number 8 here. Equilateral triangle for CAB. So that's this bottom triangle here. So CAB is equilateral. That means all sides are congruent and each angle is 60 degrees. We're told that CTB, the top triangle, is isosceles, with CT being congruent to BT. So that means these 2 sides are congruent. So that means these 2 angles are also congruent. So if we're given that this angle is 86, we have to make up 180 between these 2. So if I subtract 86 from 180, I get 94. So I have 94 degrees left to make up between this angle and this angle. So when I do that, 94 divided by 2, I get 47 and 47. So 47 and 47, sorry for the mistake there. When I do that, I add 47 and 60 because I'm looking for angle ACT. So this whole angle here. So I do 47 plus 60, and I get 107 as my angle ACT. So number 9, we are given two congruent angles. So as soon as we hear two congruent angles, isosceles. So two congruent angles or two congruent sides, we think isosceles in a triangle. So I'm given side SV is 2x plus 6, TV is 3x minus 6. Find the value of x. So like I just said, opposite congruent angles, sides are also congruent. So I set them equal and solve. I do that up here, and I get x equals 6. So now on to number 10. This is an equilateral triangle we have to draw. So triangle ABC here. So right away we know that all three sides are congruent as well as their angles. So we're given that the length of AC is 3x plus 8 and AB is 4x minus 4. So since we know that all the sides are equal, we can set those two sides equal to each other. So we set 4x minus 4 equal to 3x plus 8, and we get x is equal to 12. So now what I do is I take that 12 and I pick a side to plug it back into, because if I plug 12 into here or here, it's going to be the same thing. So I get 44. That means all the other sides are 44. And the total perimeter would be all three of those added together. So down here, I do 44 plus 44 plus 44, or just do it times 3, and I get 132 as my total perimeter. On to number 11. So number 11, we're given PR equal to PQ, or PR is congruent to PQ, and those are both sides. So that right away says it's isosceles. So that means opposite that we have congruent angles. So if that's 2x, that angle is also 2x. So what I can do is I can add up all three angles and set it equal to 180, and I solve and I get x is 35. We're looking for angle R. So I take that x, plug it back in for angle R, and I get 2 times 35. Angle R is equal to 70 degrees. And my last question here, angle A is congruent to angle C. So we have an isosceles triangle. So opposite that is going to be congruent. So if this side is 2x plus 5 and it's opposite this angle is also the same thing. So this side is also 2x plus 5. So now if I'm looking for length here, I can add all three of these up and set it equal to the total perimeter, which says is 73 centimeters. So I go ahead and do all the sides equal to 73. So 2x plus 5 twice, plus 7 plus 3x. Then I get x equals 8. I'm looking for the length of BC. So I plug that 8 back into BC, which was 2x plus 5. I do that, and I get that side BC was 20.